Good morning, Vidya. I am Dr. S. K. Srivastava from the Department of Mathematics. Today I will learn about the reference formula for the Legendre polynomial. There are the six reference formula for the Legendre polynomial, that is nPn is equal to 2n minus 1 x pn minus 1 minus of n minus 1 pn minus 2, or n plus 1 pn plus 1 is equal to 2n plus 1 x pn minus n pn minus 1. Second number, nPn is equal to xpn dash minus pn minus 1 dash. And third, 2n plus 1 pn is equal to pn plus 1 dash minus pn plus 1 dash. Fourth number, n plus 1 pn is equal to pn plus 1 dash minus xpn dash, or npn minus 1 is equal to pn dash minus xpn minus 2 dash. Fifth number, 1 minus x square pn dash is equal to n in bracket pn minus 1 minus x pn. And last, 1 minus x square pn dash is equal to n plus 1 in bracket x pn minus pn plus 1. Now we will see how the formula first is proved. We know the generating function 1 minus 2xh plus h squared to the power minus 1 by 2 is equal to summation n is equal to 0 to infinity h to the power n pnx. This is equation first. Now differentiating with respect to h, this is 1 minus 1 half 1 minus 2xh plus h squared to the power minus 3 by 2 in bracket minus 2x plus 2h is equal to summation n is equal to 0 to infinity n h to the power n minus 1 pnx. Again, this can be written as x minus h 1 minus 2xh plus h squared to the power minus 1 by 2 upon 1 minus 2xh plus h square is equal to summation n is equal to 0 to infinity n h to the power n minus 1 pnx. Again, this can be written as x minus h 1 minus 2xh plus h squared to the power minus 1 by 2 is equal to 1 minus 2xh plus h square summation n is equal to 0 to infinity n h to the power n minus 1 pnx. Again, x minus h summation n is equal to 0 to infinity h to the power n pnx is equal to 1 minus 2xh plus h square summation n is equal to 0 to infinity n h to the power n minus 1 pnx. Now multiplied by x, then x summation n is equal to 0 to infinity h to the power n pnx minus h summation n is equal to 0 to infinity h to the power n pnx is equal to summation n is equal to 0 to infinity n h to the power n minus 1 pnx minus 2xh summation n is equal to 0 to infinity n h to the power n minus 1 pnx plus h square summation n is equal to 0 to infinity n h to the power n minus 1 pnx. Again, that is x, and the expanding of summation n is equal to 0 to infinity h to the power n pnx by putting n is equal to 0, 1, 2, 3 and so on infinity. This minus h, again expanding of this summation is equal to expanding of summation minus 2x in bracket expanding of summation and plus h square. This is the expanding of summation. We will get the equation A. Now equating the coefficient of h to the power n minus 1. This is x pn minus 1 x minus pn minus 2 x is equal to n pn x minus 2 x n minus 1 pn minus 1 x plus n minus 2 pn minus 2 x. Again solving, this is minus n pn x is equal to n minus 2 pn minus 2 x plus pn minus 2 x minus 2x n minus 1 pn minus 1 x minus x pn minus 1 x. Again simplification, this is minus n pn x is equal to pn minus 2 and pn minus 2 is common, then n minus 2 plus 1 pn minus 2 minus 2 n x pn minus 1 plus 2x pn minus 1 x minus x pn minus 1, that is n pn x is equal to 2n plus 1 x pn minus 1 minus n minus 1 pn minus 2 x. Similarly, now equating the coefficient of h to the power n, then x pn x minus pn minus 1 x is equal to Pn plus 1 Pn plus 1x minus 2x and Pnx plus n minus 1 Pn minus 1x. This is minus of n plus 1 Pn plus 1x is equal to n Pn minus 1x minus 2x and Pnx minus x Pn. This is minus of n plus 1 Pn plus 1 x is equal to x Pn minus 1x minus 2n plus 1 x Pn. That is n plus 1 Pn plus 1 x is equal to 2n plus 1 x Pn minus n Pn minus 1 x. This is the proof of recurrence formula first. Now the proof of second. We know the recurrence formula 1 minus 2x plus h squared to the power minus 1 by 2 is equal to summation n is equal to 0 to infinity h to the power n pnx. This is equation first. Now differentiating with respect to h, then 1 minus 1 by 2, 1 minus 2 xh plus h squared to the power minus 3 by 2 in bracket minus 2x plus 2h is equal to summation n is equal to 0 to infinity n h to the power n minus 1 pnx. This is x minus h, 1 minus 2xh plus h squared to the power minus 3 by 2 is equal to summation n is equal to 0 to infinity n h to the power n minus 1 pnx. So this is second. Now differentiating with respect to x to equation first. This is minus half 1 minus 2xh plus h squared to the power minus 3 by 2 minus 2h is equal to summation n is equal to 0 to infinity h to the power n pn dash x. This is h1 minus 2xh plus h squared to the power minus 3 by 2 is equal to summation n is equal to 0 to infinity h to the power n pn dash x. Now from 2 and 3, this is x minus h summation n is equal to 0 to infinity h to the power n minus 1 pn dash x is equal to n is equal to 0 to infinity n h to the power n minus 1 pn x. Now x summation n is equal to 0 to infinity h to the power n minus 1 pn dash x minus h summation n is equal to 0 to infinity h to the power n minus 1 pn dash x is equal to summation n is equal to 0 to infinity n h to the power n minus 1 pn dash. On simplification, the summation and equating the coefficient of h to the power n minus 1, this is x pn dash x minus pn minus 1 dash x is equal to n pn x. This is the proof of second difference formula. Thank you.